Find the power required to drive a 40 mm power screw having double square threads with a pitch of 6 mm. The nut has to move a velocity of 48 mm per second and move a load of 10 kN. The frictional coefficients for the threads and collar are 0.1. The frictional diameter of the collar is 80 mm. Here the options are 1.26 kilowatts, 1.46 kilowatts, 1.56 kilowatts, and 1.86 kilowatts and 1.96 kilowatts. Coming to the solution, the power is given by the total torque into omega or 2 pi nt by 60 simply. Here T is the total torque, that is the total torque is equal to the torque applied on the collar and the torque applied on the threads. First consider regarding the threads, the pitch of the threads is 6 mm and velocity is equal to 48 mm per second, and the force required to lift is 10 kilonewton. Mu is equal to 0.1, that is frictional coefficient, and frictional diameter of the collar DC is equal to 80 mm, which is equal to 0.08 meters. So here the torque applied on the threads is equal to mu into F into DC by 2, where mu is the 0.1 and F is 10 kilonewton, that is 10 in 10,000, 10 in 10 cube newton, into DC is equal to 0.08 by 2, so which is equal to a value of 40 Newton meter. And now the torque applied on the collar. Torque applied on the collar is given by F into dm by 2 into tan theta plus pi, where tan theta comes from tan theta is equal led by pi dm, where dm is the mean diameter of the is equal to 40 plus 40 minus 6, that is pitch, by 2, which gives a value of 37 mm. And here lead is given by 2 times pitch, that is 2 into 6, which is equal to 12. So from this equation we get here theta is equal to 5.88 degrees, and pi is equal tan pi is equal to mu, and here pi is equal tan inverse mu, that is tan inverse 0.1, say value of 5.7 degrees. So on the substitution of all the values, the torque is on the collar is equal to 37.94 Newton meter. Now the total torque is equal torque T is equal 37.941 plus 40, which is equal to 77.941 Newton meter. And here omega comes from the formula omega by 2 pi is equal to V by lead, and from this omega is equal here it is omega by 2 pi is equal V by lead, and here omega is equal V into 2 pi by 2 into 6, which is given a value of 25.13 radians per revolution. So here P is equal T into omega, and by substituting a torque and omega we get a value of here 1.96 kilowatts. So here 1.96 kilowatts is the right answer, and in the options the correct option is D. D is the right answer. Following list with list 2 by using the codes given below, and here list 1 is partial bearings, self-acting bearings, externally pressurized bearings, self-aligning bearings. List 2 is hydrostatic bearings, journal bearings, roller bearings, hydrodynamic bearings. Here we can say that roller bearings are self-aligning bearings. Here the roller bearings only the self-aligning bearings. So here for the D the correct option is 3. And coming to the hydrodynamic and hydrostatic bearings are, here hydrodynamic bearings are self-acting bearings, but hydrostatic bearings we use some external pressure to reduce the friction. So that's why hydrostatic bearings are called externally pressurized bearings, and hydrodynamic bearings are called self-acting bearings, and journal bearings are called partial bearings. So here the correct option is D. D is the right answer. Two different pairs of sheets of same material are welded by resistance spot welding. In one pair, the average radius of each spherical bridge is 0.25 mm and the number of bridges per centimeter square is 40. In another pair, the number of bridges per centimeter square is 50 with 0.2 mm average radius of spherical bridge. The ratio of the voltage to be applied in these two cases in order to generate the same rate of heat per unit area is, here the options are 1 root 2 1 by root 2 and none of these. Here coming to the solution, here heat produced or heat required to melt is directly proportional to volume of nuggets and number of nuggets and heat required per gram. Let us say heat required to melt in case 1. First consider the case 1 is equal to volume of the nuggets 1 into and number of nuggets into heat required per gram. Let us say heat required per gram or Q. Okay, heat required per gram. But here heat required to melt is given by I square RT. Okay, or we can write it as V square by RT 1 and here is equal to V1 N1 heat and Q per gram. And in the second case also we get the same equation, but here first consider for the second case also it is equal to V2 into N2 into heat per gram. But here we use the same material because two different pairs of sheet metal of same material of sheets of same material are welded by resistance spot welding. So that because they are same material, here T1 is equal to T2 as well as R1 is equal to R2 such that Q per gram also is equal to Q per gram in both the cases. Let's say this 2 and this is 1. So now here we have V square 1 by V square 2 is equal to V1 N1 by V2 N2. This V represents the voltage and this V represents volume of the nuggets. Here V1 by V2 is equal, let us say V1 square by V2 square is equal, here this is the volume of the nuggets is 0.25 into 40 number of nuggets and it is 0.2 into 50 which is equal to 1, that is V1 by V2 is equal to 1, that is the ratio of voltages for both the cases is equal to 1 and the correct answer is A. A is the right option.